Hello, we are moving on to two-way tables. These aren't as bad. I think that these kind of intuitively make sense to some, so hopefully two-way tables are seen a lot on standardized tests. Alright, so a two-way table is a way to organize information from two different categories. One category is represented by rows and the other category is represented by columns. For example, the table below shows the results of a survey of people who buy ice cream at the Freeze. So delicious. Puppy Chow is the best freeze there, by the way. The results are divided into two categories, age and gender. And we can see the results of that in our table. So 50 and under, there are 23 males that are 50 and under and 19 females. There are over 50, 45 males and 13 females. Now, this survey gives us a lot more information than we directly see. So it may just break it down into those four pieces, but how many people were surveyed? It doesn't tell me that, but I know I can figure it out. Because if I look at males and females, 23 males in this category and 45 in that one, there are 68 males total. I add the different categories of females, there are 32 females total. So if there's 68 males and 32 females, I just add those together to get 100. Or I could look at it the other direction. How many people were total under 50? 23 males, 19 females, I add those together and I get 42. Over 50, 45 males and 13 females, that's 58. And again, 42 and 58 adds to 100. That always has to be true. We can't add these totals and get a different number than those totals. If that happens, you added something wrong. So how many people were surveyed? 100 people. How many people were over 50? Over 50, we see that right there. There were 58 people that were over 50. How many females were surveyed? I see that right here. All the females from all the different categories, there are 32 females that were surveyed. See, not so bad. All right, so let's look at some probabilities with these two-way tables. Now, I want to remind you, probability is simple, and it always comes down to probability is success over total. So if I want the probability of from the customer from the survey above is chosen at random. Random is really important. I want that person to be male. It is success over total. So how many different chances do I have of choosing a male? Well, I look back at that table. I'm not going to scroll up and down every single time, but if I look back at this table right here, I see 68 males. So if I'm choosing one from random, my table showed me that there were 68 chances for me to get that correct. Out of all the people surveyed, 68 chances for me to pick a male. Out of the total, there's 100 people surveyed. We reduce that down to 17 over 25, which is 0.68. Remember, we can do decimals or we can do fractions. So if I want the probability of female, if I look back at my chart, there were 32 females out of the 100, which reduces down to 8 over 25, which is 0.32. Either one, doesn't matter which one you use. Probability of over 50. So again, we go to our table and I want anyone that's over 50. It could be male, it could be female, which means I'm looking at this, whoops, wrong one. Over 50 right here. I can see it doesn't care if it's a male or a female. I just want that person to be over 50. There are 58 people over 50 out of the 100 total surveyed. That reduces down to 29 over 50, which is 0.58. I should write those zeros in front. All right, now we're going to get a little bit more specific here. The probability that they're a male and they're over 50. So I'm getting more specific here. They need to fit both criteria. It can't just be a guy. It can't just be over 50. It needs to be male and over 50. So I go back to my table. I'm looking male and over 50. This is the value that I'm looking for. This is how many are fitting both the over 50 and the male category. So we see that that is going to be, there are 45 out of the total 100 people. Reduces down to 9 over 20. We're just going to be sticking with fractions. Male or over 50. Okay, so let's see this. This said it had to be both. It had to be male and over 50. It couldn't be one or the other. Now it says male or over 50. So it's one or the other. So if I'm looking back up there, it could be over 50. So now I go back to my two-way table. This is where I'm going to find all of that really important information. So it's all males. So it's males 50 and under, it's males 50 and over. But it's also anyone over 50. So it's also including the females that were over 50. So I need to, I need to include anyone male or over. So that big difference between and or. So I'm going to add up all three of those categories. So there were 23 males under 50. There were 45 males over 50. And there were 13 females over 50 out of the 100 total. So that gives me 81 over 100 is that probability. Next, probability female and over 50. All right, so we're back to that and, which means that the category has to fit both. I'm going back up to my chart. I know you're tired of me going up and down, up and down. All right, so we have female and over 50. Here's the females, but I don't want the females under 50. I'm only looking here. There are only 13 females that are over 50 from the survey. And that doesn't reduce, so that's my answer. Next one, probability that they are female or male. Well, let's think about who we surveyed. We only surveyed males and females. So the probability that's a male or a female, that includes our entire population. So we have a 100% chance of making that happen. No matter who I choose at random, they're either going to be male or female based on our sample space. All right, second page. Turn on over. Now we're going to look a little bit closer at the different parts of the two-way table. There is joint frequency, which is just the individual entry in the table. Marginal frequency is the sum of the rows and columns in the table. We looked at both of those on the front page without even talking about it. Those were our totals. The following table represents the results of a survey given to juniors and seniors about going to prom. So the ones attending, not attending, who were the juniors, who were the seniors, and then I gave you the totals. Now, joint relative frequency is an individual entry over the total surveyed. All of these vocab words they're just vocab. I feel like we don't even use them. But it's important that you know what they are, but don't let yourself get overwhelmed with all of the different vocab because the questions generally don't use the vocab words. It's about being able to figure out what the probability is going to be. All right, so what is the probability that a random student selected is a junior that is attending prom? So we're looking for the probability of a junior who's attending prom. We are looking for the joint relative frequency Joint frequency over total survey. So juniors attending prom. Let's see the juniors attending right here. That's our joint frequency. It is an individual entry in the table. Over total surveyed, we surveyed 400 people. So 140 over 400 reduces down to 7 over 20.35. So that's joint relative frequency. Again, that's one entry over the total. Then there's marginal relative frequency, a marginal total over the total surveyed. Marginal frequency over total surveyed. What is the probability that a random student selected is not attending prom? Probability that they are a student but no prom. So it is marginal because it isn't one entry, because it's any student not attending prom. So it could be either the juniors not attending, or it could be the seniors not attending. That is why it's marginal. It's that total. There are 60 juniors and 40 seniors over the total surveyed. So that gives us 100 over 400, reducing down to 1 over 4. A quarter is that probability, 1 out of 4 students not attending prom. All right, and then the last one is conditional relative frequency, an individual entry over a marginal total. So joint frequency over marginal frequency. What is the probability that a random senior, that's our change there, selected is attending prom? So the other ones, our sample space was that a random student, we were pulling from the total surveyed. It could be any random student. Now this one, it didn't say what is the out of a random student, it was out of a random senior. So my sample space isn't all 400 students, it's only of the seniors. Here's that conditional probability. So what is the probability that they are going to prom given that they are a senior? All right, let's go back up here. So we're looking at the seniors that are going to prom right here. Seniors attending. So there are 160 seniors who are attending prom over the 200 seniors that were surveyed. Again, the difference is we are not pulling from the total survey. We were limiting our sample space to just those seniors. That reduces down to 4 over 5.80. So as things are starting to get a little crazy in your mind, always think back to probability comes to how many ways can you be successful out of those total possible outcomes. Again, number 3 was different because I wasn't pulling from all people. I was only pulling from the seniors. So my sample space wasn't that 400, it was the 200. All right, and that is it for our two-way table video.